Mm, Hello, I welcome you all in this series of basic real analysis. And today's topic, as I told you, was Cauchy sequence. We were discussing Cauchy sequence for a while now, and it is the third lecture in this particular series. And today also, I'm going to take a few questions, you can say, and a few of the results that are very useful for your exam also when it comes to conversions in general. Okay, but right now at first I'll again focus on the Cauchy sequences. See, in R, that is if it is a complete metric space, then there's a powerful theorem which suggests that a sequence is convergent if and only if it is Cauchy. So that way, it is a very important result. So if you know that your sequence is Cauchy, then okay, so then it will be then it is quite useful. Okay, so then it is quite useful. Now you see, okay, so let me begin the session by a few questions, and then as I go on, you'll be able to understand things better. Okay, so a few things that we've already done. We've already stated the contractive sequence, and we've stated that a contractive sequence is a Cauchy sequence. Okay, a few of the things that I'm going to do today. Again, as I told you, I'm going to do much of the uh, much related to Cauchy sequence today. Uh, okay, so just wait a minute for people to join in, and once they join in, I will start. Okay. Okay, so yesterday we were doing some questions, and today also I'm going to do some questions on Cauchy sequence. Let us start. So these were the questions that I did yesterday, and today I'm going to do a few more on the same. Okay, so let us start. So what do you think about this sequence? Is it a Cauchy sequence? Is it a Cauchy sequence? The sequence that I'm writing just right now. Okay, is it a Cauchy sequence? Think about this. Why it is not? Think about this. Okay, think about this. Whether it is a Cauchy sequence or not. So we have done all like this series, this sequence. An equals to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 dash dash 1 by n. So do you think that this is a Cauchy sequence? It is not. Okay. Do you think it is a Cauchy sequence? Okay. Do you think that it is a Cauchy sequence? Okay. So what was the definition for Cauchy sequence? Definition for Cauchy sequence was that a sequence is said to be Cauchy. A sequence, let's say an, is said to be Cauchy. Is said to be Cauchy if modulus of am minus an can be made less than epsilon for all m greater than n greater than equals to n naught belongs to natural, right? So this is how you define your Cauchy sequence. This is how you define your Cauchy sequence. Now you see, this is your particular this particular sequence is what 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 dash 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 1 by. If I have to prove this, if I have to prove that this is a Cauchy, then I have to do this. Now let us take let us take m to be equals to what? M to be equals to 2n. Let us take m to be equals to what? 2n. Then if the sequence is Cauchy, if the sequence is Cauchy, then a to n minus of a to n, sorry, a to m, a to n minus of a n can be made less than epsilon for all n greater than equals to some n naught. Okay, so if you have this kind of thing, that if I'm stating that this particular sequence is Cauchy, if I'm stating that this particular sequence is Cauchy, then what I can do, okay, if I'm stating that this particular sequence is Cauchy, then what I can do, okay. In the previous lecture, we were discussing Cauchy sequence. Today also we are going to study with the Cauchy sequence. Let us begin. So the first question that I'm asking today is this. Okay, just tell me whether this is a Cauchy sequence or not. Just tell me whether this is a Cauchy sequence or not. So the sequence I'm giving you is an is equal to 1 plus 1 by 2 plus 1 by 3 dash 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 1 over n. If this is the sequence, then what do you think that whether this would be a Cauchy sequence or not? So I told you on previous two lectures that a sequence is said to be Cauchy. A sequence is said to be Cauchy. A sequence is said to be Cauchy. A sequence is said to be Cauchy if modulus of am minus an can be made less than epsilon for all n greater than equals to n naught belongs to natural number. Okay, so corresponding to a given epsilon, I must be in a position to give you an n naught. I must be in a position to give you n naught such that am minus an, the modulus difference can be made less than epsilon. Now, if this sequence is Cauchy, if this sequence, that given sequence an is equals to 1 plus 1 by 2 plus 1 by 3 dash 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 1 by n is Cauchy, then the difference am minus an can be made less than half also for some n. For some n, let us say capital N. Now, let me take m is equal to 2n. Since m is what? M is obviously greater than m is obviously greater than n. M is obviously greater than n according to the definition of the Cauchy sequence. Am minus an can be made less than epsilon for all m greater than equals to n naught, right? So if I take m equals to 2n, I don't think I'm making any mistake. So if the sequence is Cauchy, then a minus an can be made less than epsilon, and let epsilon be equals to what? Half. Let epsilon be equals to half. So in that scenario, I can write that a to n minus an can also be made less than half for some n. For some n, let's say capital N. Why? I'm saying only when this is a Cauchy sequence, only when it is a Cauchy sequence. Since I'm claiming that my sequence is Cauchy, then a to n minus an mod can also be made less than half for all n greater than equals to n belongs to natural number. But what do you see? What would be a to n minus an? A to n minus an would be what? A to n minus an would be what? Just think about it. It will be equals to 1 upon n plus 1, 1 upon n plus 2, dash 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 1 upon 2n, right? And it will be greater than what? It will be greater than 1 upon 2n plus 1 upon 2n plus 1 upon 2n dash 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 1 upon 2n. And how many 1 upon 2n's are these? These are n 1 upon 2n. So I can write my a to n minus an mod will always be greater than equals to n for all n belongs to natural. Okay, so here we arrive at a contradiction. So see, I claimed that my sequence is Cauchy. If my sequence is Cauchy, then you should understand that am minus an modulus can be made less than epsilon. Let epsilon be equals to half and let m equals to 2n. So if my sequence is Cauchy, then a to n minus an mod can be made less than half also for all n greater than equals to some natural number. But what happens is a to n minus an can never be made less than half. So if the sequence is Cauchy, then for any given arbitrary epsilon, I must be in a position to give you a natural number beyond which the sequence element should be in such a way that a to n minus an mod is less than half. But what do you see? You see that a to n minus an is always modulus is always greater than So clearly the sequence given by an equals to 1 plus 1 by 2 plus 1 by 3 dash 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 1 by n is not a Cauchy sequence. Okay, now think about this. Think about this. Okay, now just think about this, and I'm going to do a question for you, and then probably you'll be able to answer me. Okay, now just think about this question. I'm giving you conditions for Cauchy sequences. Okay, just I'm giving you conditions for Cauchy sequence, you have to verify. Okay, now I'm giving you some conditions for the Cauchy sequence and you have to verify. Okay, let xn be a sequence in R. Let xn be a sequence in R, and which of the following conditions then ensures, which of the following condition ensures that xn is a Cauchy sequence? Which of the condition ensure that xn is a Cauchy sequence? First, limit n tends to infinity modulus of xn plus 1 minus xn equals to 0. So if xn is a sequence in R, which of the following condition ensures that xn plus 1 minus xn modulus limiting value is equals to 0? Just let me know. May I know how many people are there on chat? If there are people and who know the answer, please let me know. So what am I asking? I'm asking that if xn is be a sequence, which of the following conditions ensure that xn is a Cauchy sequence? So if I'm saying that limit n tends to infinity xn plus 1 minus xn equal to 0, does it imply that xn is a Cauchy sequence? Answer is no. Answer is no. Okay, answer is no. Why? Take xn is equals to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 dash 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 1 upon n. Now what would be xn plus 1? Xn plus 1 would be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 dash 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 1 by n plus 1 upon n plus 1, right? This would be your xn plus 1. Now if I take xn plus 1 minus xn modulus and take a limit of it, what do I get? I get 0. But I know that xn is not a Cauchy sequence. It is not a Cauchy sequence. So the condition that limit n tends to infinity xn plus 1 minus xn should be 0 for a Cauchy sequence is false. Okay, so if a so which of the condition ensures that xn is Cauchy? No, not at all. This condition may be valid even if you take xn to be a non-Cauchy sequence. You just take this sequence. Clearly I showed you just above that this particular sequence is not a Cauchy sequence. However, this particular sequence is actually satisfying this condition, that is limit n tends to infinity xn plus 1 minus xn, it is coming out to be equal to 0. If it is, see, because you know now, because xn plus 1 minus xn, what it would be? It would be simply limit n tends to infinity 1 upon n plus 1. And if limit n tends to infinity 1 upon n plus 1 is what? 0. So clearly this particular sequence is validating this particular statement. However, we know that xn is not a Cauchy sequence. So clearly this particular condition uh, does not ensure that xn is a Cauchy sequence. I hope it is clear. Now just think about this. Now just think about this. Now just think about this. Xn plus 1 minus xn mod is less than equal to 1 upon n. Xn plus 1 minus xn mod is less than equal to 1 upon n plus 1. My xn plus 1 minus xn mod is less than equal to 1 upon n plus 1 1 upon n. Okay, sorry. Do you think that this ensures, do you think that this condition ensures that xn is Cauchy? Do you think that this condition ensures that xn is Cauchy? Answer is again no. Why? Again take example, xn plus 1 is equals to 1 plus 1 by 2 plus 1 by 3 dash 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 1 upon n plus 1, and take xn is equals to obviously 1 plus 1 upon 2 plus 1 upon 3 dash 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 1 upon n. Clearly, if I take xn plus 1 minus xn mod, it will always be less than 1 upon n. Clearly, it is always less than 1 upon n. See, because xn plus 1 minus xn would be what? So, xn plus 1 minus of xn modulus would be equals to what? It would be equals to 1 upon n plus 1. And clearly, it is less than 1 upon n. So, this particular sequence which is xn is equal to 1 plus 1 by 2 plus 1 by 3 plus dash 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 1 upon n satisfies this condition. However, this particular sequence is not a Cauchy sequence. So clearly you can state that that this condition also does not ensure us this condition also does not ensure that the sequence xn is a Cauchy sequence. Okay, so what we are doing, please remember, again I'm telling you this, these are very important questions for your examination. Question says that let xn be a sequence in R. Which of the following condition ensures that xn is a Cauchy sequence? Which of the following condition ensures that xn is a Cauchy sequence? So option number 1 was limit n tends to infinity xn plus 1 minus xn mod is equal to 0. No, this condition does not ensure that xn is a Cauchy sequence. Just for giving a counter, I have taken an example, xn is equal to summation 1 upon n. So clearly this if I take this particular sequence, that is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 dash 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 1 upon n, then this indeed satisfies this condition, but I know that xn is not a Cauchy sequence. Similarly, do you think that if xn plus 1 minus xn ka mod is less than equal to 1 upon n, does it satisfy that xn is a Cauchy sequence? No, not at all. Not at all. Now, what do you think about this? If xn plus 1 minus xn mod minus xn whole mod is less than equal to 1 upon n square, do you think that this satisfies the condition for Cauchy sequence? Do you think that this satisfies the condition for the Cauchy sequence? Do you think that this satisfies the condition for the Cauchy sequence? So answer is indeed yes. Answer is indeed yes. So this satisfies the condition for the Cauchy sequence. Yes. So answer is indeed true. So how to go about it? I'll explain. So I told you on the very first day, if I have to establish this, what will I do? I told you that if I have to establish that a sequence is Cauchy, what do I need to do? I need to take an estimate of xm minus of x, isn't it? In order to establish that a sequence is a Cauchy, then I need to estimate what? I need to estimate, I'm writing, I need to estimate, what do I need to estimate? I need to estimate modulus of xm minus xn, and whether it can be made less than epsilon for some m greater than n greater than equals to m naught belongs to natural. So for all m greater than n greater than equals to n naught belongs to natural, if xm minus xn can be made less than epsilon, only then I would say that my sequence is a Cauchy sequence. So please pay heed to this. This is an important question for your exam. So what I am writing, I have taught you that if xn is a, if I'm teaching you right now that if xn is a sequence in R, which of the following condition ensures that xn is a Cauchy sequence? The first condition is violated by using this example. So limit n tends to infinity, xn plus 1 minus xn mod is equal to 0 if it comes. It does not necessarily imply that xn must be Cauchy. I have taken this counter example. If xn plus 1 minus xn mod is less than equal to 1 upon n, does this condition ensure that xn is Cauchy? No, because again take counter example, xn is equal to summation 1 upon n. I know that xn is equal to summation 1 upon n is not a Cauchy sequence. Now let us estimate. Now I am saying that if I take xn plus 1 minus xn mod less than equal to 1 upon n square, then indeed it does satisfy that. Indeed it does. You can say. Indeed, here I can say that xn must be a Cauchy sequence. Let us see how. Let us see how. So what I have to do, I have to estimate xn minus xn, xm minus of xn, and see what is x here. Hint is given to us in what? Here the hint is given to us in the difference of the consecutive terms. So what I am going to do, and this I am evaluating for all m greater than n greater than equal to some n naught belongs to natural. Okay, so there is some m here, there is some n here, okay. So this would be n plus 1, this would be n plus 2, this would be m minus 1. So what I can do, I can estimate xm minus of xn, and what I'll do, I'll simply write xm minus of xm minus 1 plus xm minus 1 minus of xm minus 2 plus xm minus 2 minus of xm minus 3 dash dash xn plus 2 minus of xn plus 1 plus xn plus 1 minus of xn mod. Isn't it? If I cancel it out, so all will get cancelled and I'll only get xm minus of xn mod. Now if I apply triangles inequality here, so this will be less than equal to xm minus of xm minus 1 modulus plus xm minus 1 minus of xm minus 2 modulus xm minus 2 minus of xm minus 3 modulus, and then I can go all along. I can write xn plus 2 minus xn plus 1 modulus plus xn plus 1 minus of xn modulus. Okay, now this is one thing. Now I already know that xn plus 1 minus of xn is less than equal to 1 upon n square. Xn plus 1 minus of xn is less than equal to 1 upon n square. So if I write in that way, what it would be equal to? This would be equal to what? So if I'm writing xn plus 1 and here I'm writing xn and I'm writing it is less than equal to 1 upon n square. So it will be less than equal to 1 upon m minus 1 whole square. This would be less than 1 upon m minus 2 whole square. This would be less than 1 upon m minus 3 whole square dash dash dash. This would be less than 1 upon n plus 1 whole square, and this would be, this particular thing would be less than equal to 1 upon n square. Okay, so I know that my m is greater than n, so I can write that 1 upon m will be less than 1 upon n. So similarly, if I write this particular thing as less than, so what I can do, so my m is already greater than n. Okay, my m is already greater than n. My m minus 1 is also greater than n. My m minus 2 is also greater than n. So what I can do, I can compare all this equation by 1 upon n square. So obviously 1 upon n square would be greater than 1 upon n is greater than 1 upon n, and I know that even m minus 1 is greater than n, so I can write 1 upon m minus 1 is also less than 1 upon n. So I'm writing 1 upon n square, this also less than 1 upon n square, this also less than 1 upon n square, dash dash dash, all these things less than 1 upon n square. Okay, how many 1 upon n square do you think here there are? So there are in totality, there are in totality n minus of m minus 1 plus 1. So in totality you have n minus of m minus 1 plus 1. These many you can say, these many you can say 1 upon n square. So this would be less than n minus of m minus 2 divided by n square. And just think about this, it will be less than n upon n square. And I know that limit n tends to infinity 1 upon n is equals to what, 0, because this will be 1 up n upon n square would be 1 upon n, or in other words I can say that 1 upon n minus 0 can be made less than epsilon for all n greater than equals to n naught, isn't it? So what does it imply? It implies that xm minus of xn, xm minus of xn can be made less than epsilon for all m greater than n greater than equals to n naught belongs to natural number, implies xn is a Cauchy sequence. Xn is a Cauchy sequence. Okay, now anybody would be tempted to ask me that if these are the steps that we are going to follow in the exam, how are we going to clear the exam? Because see, in any case, if somebody says that these are the steps that you need to follow, then things will be very difficult. Obviously they will be very difficult for you. You will not be able to clear the exam. You will be thinking that how to clear the exam if these are the steps you have to follow. So I'm giving you a respite. See, I'm giving you respite. Just think about this. So if xn plus 1, uh, if xn, okay, so if xn plus 1 minus xn modulus is less than, or let's say equal to bn, and summation bn is a convergent series, if summation bn is a convergent series, then always remember that xn would be a convergent or Cauchy sequence in R. Always remember. See, why am I telling you this? This is an easy thing for you. Probably many of you might have not gone through this series thing. So I'm not deriving it as such, but always remember that if, and this is something that I'm going to derive in your, let's say, whenever you are going to do series, whenever you are going to do the series part, there I'm going to derive it for you. Okay, so what does it mean? The first thing that you should understand is that whenever you have xn plus 1 minus xn mod less than equal to bn, and bn is less than bn and summation bn, and summation bn is a convergent series, then xn is a convergent sequence. Then xn is always a convergent sequence. Remember this, or you can say xn is always a Cauchy sequence. Now let us do a question from TIFR, and then I will take a lead from here. I will take a lead from here. If any one of you knows the series, then I may help you out. But today I don't think there is an attendance. So once people would join in, then I will always do the question. So this is a question from TIFR. This is a question for TIFR. Now you see, let me do that question for you, and then you will be able to understand. Okay, just let me help myself with the question, and then you'll be able to understand what I want to convey. Okay, if I think most of you know about series, so I'll do it for you. I'll do the derivation part also for you, the proof part also for you, so that you are not perturbed by what I have written. So see, what I have written here is, see, if I'm stating that xn plus 1 minus xn mod is less than equal to bn, what I'm writing? I'm writing that xn plus 1 minus xn mod is less than equal to bn, and summation bn is a convergent series, and summation bn is a convergent series, then always remember that xn is a Cauchy sequence. Always remember that xn is a Cauchy sequence in R. Xn is a Cauchy sequence in R. And for this, I have already, probably you may know that xn plus 1, sorry, you may know that summation 1 upon n square is a convergent series. If a few of you have gone through your BSc course, probably, then you should know that summation 1 upon n square is a convergent series. Since summation 1 upon n square is a convergent series, therefore this question, instead of going through this whole routine procedure, you could have written directly this, that xn is a Cauchy sequence in R. See, in order to prove it, you will have to go through all these long steps. But if I'm saying that, just think about the portion which is written on the right hand side. So just think about this. If this is being summed, and this series, that is summation 1 upon n square, summation 1 upon n square is what? It is a convergent series. Always remember that if xn plus 1 minus xn is less than equal to something, let's say bn, and summation bn is a convergent series, then xn is a Cauchy sequence in R. Since I know that summation 1 upon n square is convergent, so therefore xn is a convergent sequence. Therefore xn is a convergent sequence. So I hope you are able to conceive the idea, or should I do it for you? See, let me do it for you. Let me first do it for you. So what I have stated, see, always remember what is a series. A few things that you should write. First, let me write a few things, and then I'll proceed. See, always remember what is a series. Let us say if I'm saying summation an is a series, that implies a1 plus a2 plus a3 dash 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 an, and then it goes on. So this is from k equals to 1 to infinity. So this is your infinite series. This is your infinite series, right? This is your infinite series. Now, always remember, a series behaves the same way as its SOPS does. The series behaves the same way as its SOPS does. What is SOPS? SOPS is a sequence of partial sum. So if your sequence of partial sum is convergent, then the series is convergent. If your sequence of partial sum is divergent, then the series is divergent. What is a sequence of partial sum? Let us take an example and understand. Let's say I'm writing summation 1 upon k. I'm writing summation 1 upon k. What is summation 1 upon k? It is 1 plus 1 upon 2 plus 1 upon 3 plus dash 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 1 upon n, and this is from k equal to 1 to infinity. I'm referring to an infinite series. This will go on. What will be the sequence of partial sum? Sequence of partial sum Sn would be simply 1 plus 1 upon 2 plus 1 upon 3 dash 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 1 upon n. This would be sequence of partial sum. and we have proven in the very start of the lecture that this particular sequence that is 1 plus 1 by 2 plus 1 by 3 dash 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 1 by n is a non-Cauchy sequence. Okay, it is a non-Cauchy, or it is a non-convergent sequence, isn't it? So it is a non-convergent sequence. It is a non-convergent sequence. Since it is a non-convergent sequence, so therefore summation 1 upon n, that is the harmonic series, is a divergent series. Okay, now you see, if I'm saying, just think about this. If I am saying that xn plus 1 minus of xn mod can be made less than bn, where summation bn, or I can write summation bk, k equals to 1 to infinity, is a convergent series, then xn is a convergent sequence, or it is a Cauchy sequence. Let us see how. Let us see how. Let us see how. So what I wanted to say, let us see how. See, in order to establish that xn is a Cauchy sequence, what will I do? In order to establish that xn is a Cauchy sequence, what will I do? I will estimate, as usual, xm minus of xn, right? I will estimate xm minus xn, where m is greater than n. So m is greater than n. So you will get n plus 1 here, you will get n plus 2 here, and dash 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 here you will get m minus 1, so on and so forth. As usual, that I did just a little bit before, that xm, it can be written less than xm minus of xm minus 1, if you remember modulus, plus modulus of xm minus 1 minus xm minus 2 modulus dash 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 modulus of xn plus 1 minus of xn, if you remember. Now you know this can be written less than, bm minus 1, this can be written less than bm minus 2, this can be written less than equal to bn, this can be written less than bn, right? What it would be, just think about this, what it would be. So what it would be, now understand, here I'm writing it. So if summation bk is a convergent series, if it is a convergent series, then the SOPS must be convergent, then its SOPS must be convergent. And what is its SOPS? The SOPS would be b1 plus b2 plus b3 dash dash dash, some, let's say I'm writing sk, then it is till bk. What do you think this would be? This would be simply this particular thing. This particular thing would be simply what? This particular thing would be simply, I can write this particular thing simply as Sm minus of Sn. Just think about it. I can write this entire thing as Sm minus of Sn, isn't it? What is Sm? Sm would be b1 plus b2 plus b3 dash 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 bm. Then I can write, I think I can write till, what is this? Bm minus 1. No? So I can write, I'm writing it so that you will be able to understand. This will be b1 plus b2 plus b3 dash 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 bm. Okay, and what would be Sn? Sn would be b1 plus b2 plus b3 dash 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 bn. I guess this would be it. So this particular thing we are evaluating for, this particular thing we are evaluating for all m greater than n greater than equal to some n not belongs to natural, right? So if I'm evaluating it for all m greater than n, so this would be it. This is absolutely fine. I don't think there is an issue till now. This would be n plus 1, this would be n plus 2, I guess this is right. This would be m minus 1, this is also right. And if I want to write xm minus xn, I'll write xm minus 1 plus xm minus 1 minus xm minus 2 plus xn plus 1 minus of xn. Till now I think everything is clear. I think this will be how it can be written. Now you see, I'm saying that summation bk is a convergent series. So if it is a convergent series, then the sequence of partial sum must converge. That is, I can write that my sk, which is b1 plus b2 plus b3 dash 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 bk, must be a Cauchy sequence. I can write that this must be a Cauchy sequence. This must be a Cauchy sequence. Okay. So if this is a Cauchy sequence, then what? Then I can say that. Then I can say from here that Sm minus of Sn mod can be made less than epsilon for all m greater than n greater than equal to some n not belongs to natural, right? Isn't it? Just think about it. And if I want to go a step ahead, so this is this way, and then I can write this to be less than modulus of bm minus 1 plus bm minus 2 modulus dash 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 bn modulus. If they are positive, then it will be fine. Otherwise, I can write in this fashion. Isn't it? Yes or no? Just think about this. Just think about this. Just think about this. What is this? Is it not equal to writing Sn minus of, see what is Sm? Sm would be b1 plus b2 plus b3 dash 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 bn, isn't it? Plus bn plus 1 plus bn plus 2 dash 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 bm. Okay, is it not equal to writing Sm minus 1 minus Sn minus 1? So if sequence is Cauchy, then Sm minus Sn can be made less than epsilon. Similarly, Sm minus Sn minus 1 mod also can be made less than epsilon for all m greater than n greater than equals to n not belongs to natural. I hope it is clear. So if your sequence xn is such that xn plus 1 minus xn mod can be written less than equal to bn or simply less than bn, and bn is a convergent series, then xn is a Cauchy sequence. Again, I'm reiterating how. See, and for understanding that it is a Cauchy sequence, let us first take an estimate of xm minus xn modulus. So if I'm taking the estimate of xm minus xn modulus, then what it would be equals to? It would be equals to xm minus 1 plus xm minus 1 minus xm minus 2 dash 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 xn plus 1 minus of xn. This is something that I have already done in previous steps also. This would be less than bm minus 1, this would be less than bm minus 2 dash 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 bn, and it would be less than modulus of bm minus 1 bm minus 2 dash 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 bn. Just think about this, what it would be equals to. This particular thing is equal to sm minus 1 minus sn minus 1. How can I say that? See, if summation bk is a convergent series, then the SOPs corresponding to this particular series must be convergent. Then that is, if I'm saying that summation bk is a convergence series, then sk, which is b1 plus b2 plus b3 dash 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 bk, this should also be a convergent sequence, because corresponding to a convergence series, its SOP is, that is the sequence of partial sum, must be a Cauchy sequence. So what is SK? It is B1 plus B2 plus B3 dash 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 BK. What is SM? It is B1 plus B2 plus B3 dash 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 BM. And in between you will have a BN also, because clearly see M is way too greater than N. So I'll write Sn is equal to B1 plus B2 plus B3 plus Bn. And what is your what is your SM? SM is B1 plus B2 plus B3 Bn, then Bn plus 1 plus Bn plus 2 dash 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 Bm. Just think about this. Just think about this and think that can it not be written as Sm minus 1 minus of Sn minus 1? And what it would be? Since I'm saying that sequence Sn is Cauchy, then Sm minus Sn modulus can be made less than epsilon. Similarly, I can write Sm minus 1 minus Sn minus 1 modulus can be written less than epsilon. It implies what? It implies that xm minus xn modulus is less than epsilon. It implies that xn is a Cauchy sequence. It implies that xn is a Cauchy sequence. I hope you might have got this particular topic. I'm going to upload a lecture containing you can say this concept, and it has been asked previously in NET exam, in TFR examination, also in the NBHM examination. So I hope to meet you tomorrow. Please do come in full strength in this lecture. I'm taking your 1 hour of the life. If you're going to give me 1 hour of your life, I'm claiming it that when you are going to give your examination, you will be 100% at the real analysis. So I hope that you will trust me. Till then, take care. Bye bye.